and then you integrate. Just follow these steps and you will do great. First you separate, and then you integrate. Just follow these steps and you will do great. First you separate, and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing. Problem after problem until the day's end.
Okay, greetings math people. Today we're going to look at a problem from the MIT Integration Bee. So this problem is number 1 from 2006. So this is the first problem of the 2006 MIT Integration Bee. Now this problem actually was not solved by the contestants. So the time elapsed before any of the two contestants could solve the problem. But we're going to take a look at it. It's a fairly easy problem to solve when you look at it the right way. So the problem we have is the integral of the square root of x over 1 minus x cubed dx. So you're thinking, my thinking at least, is when I see a square root, and particularly when a denominator starts with 1 minus something or any constant minus something, I think about arc sine. So my first way to look at this is try to turn this somehow into an arc sine problem. Now, of course, in the form of arc sine, you know, the integral is the integral of du over the square root of a squared minus u squared. So there isn't a radical in the numerator. But since our numerator is just x, we can express the square root of x without a radical. So we could rewrite this problem as the integral of x to the 1/2 power over the square root of 1 minus x cubed. So if the arc sine format is going to work, then we need to write this as something squared. So basically we'll take the square root of x cubed and square it. So the square root of x cubed is x to the power of 3 over 2. So we're going to write x cubed as x to the power of 3 over 2 squared. So it's the integral of 1 over the square root of 1 minus x to the power of 3 over 2 squared. X to the 1/2 on top. So if this is going to work, we're going to have to make u equal x to the power of 3 over 2. And hopefully when we take the derivative of u, we get something that corresponds with x to the power of 1/2. So let's see what happens. So if u is x to the power of 3 over 2, then du would be 3 over 2 x to the power of 1/2. So there's the 1/2 we wanted. Now of course, 3 over 2x to the power of 1/2 dx. Of course we just want this to be just x to the 1/2 dx, not 3 over 2x to the 1/2 dx. So we'll simply multiply both sides by 2/3, and we have that 2/3 du is x to the 1/2 power dx. And so now we have a beautiful match. So our numerator here is x to the 1/2 dx. Well, x to the 1/2 dx is 2/3 du, 2/3, put outside the radical, du on top. Our denominator is 1 minus x to the 3/2 squared, but again u is x to the 3/2, so this is the square root of 1 minus u squared, and this is the perfect format for arc sine. So then the answer is 2/3 arc sine of u, but u is x to the power of 3 over 2 plus some constant. That actually is the answer. So the problem wasn't as bad as you may have thought if you take the right approach.